Hello, Assalamualaikum warahmatullahi wabarakatuh. We are from KASA Smart Recycling Center. I will introduce to you our group members. Me, myself, Nurul Kamila binti Hussein Elias Norman. And my group members are Nur Aida Najah binti Ismail Najib, Ahmad Abrar Hakim bin Saidan, and Muhammad Izzul Shukri bin Misnan. So this is the objective of KASA Smart Recycling Center. Firstly, we propose to make a smart recycling center with monitoring system to monitor the level of the recycle bins and to increase the bin space using compacting system. Secondly, we propose to make an auto payment system for a smart recycling system using QR code system. As shown in the slide is the timeline for KASA smart recycling system. From this timeline, we can see that from week 1, we have done team discussion, brainstorming ideas, planning ideas, and writing proposal idea. This proposal idea have been submitted during week 3. From week 3, we are attending Raspberry Pi workshop and doing project planning. Project planning is continued until week 5. From week 4, we are doing sketching and designing ideas, doing midterm design review report. For sketching and designing ideas have been continued until week 6, and the midterm design review we have submit during week 10, and the product simulation should be done during week 8, and the prototyping project design will be continued until week 14. For the product testing, we will test our product during week 10, and drafting the project report from week 11 and will be submit during week 14, and week 14 will be the project exhibition.
Assalamualaikum and hi, my name is Abrar. So I'm going to explain about our group project purpose method. Purpose method of smart invention for recycling center at USIM consists of 3 main parts. For the first part, level monitoring level function to detect the level in every recycle bin in the center. The system using sonar or ultrasonic sensor to operate and implement IoT-based monitor through TeamSpeak, which is the website that allow upload and data reading from the sensor. With TeamSpeak, location of the recycle center can be determined. The system also notify management department by email. For the computing system, it's operated to increase the space of the recycle bin. The system uses DC motor to control the compactor to compact the trash or waste in the bin at the preset level or when the level is full. It can be operated either automatically or manually using push button. Auto payment system is using load cell to detect the weight of the recycled materials. The payment is based on the weight of the trash. The data then encoded into QR code that generated by Raspberry Pi and scanned by customer using mobile apps. The data also sent to the customer using email server.
My name Muhammad Izzul Shukri bin Misnan. For the current stage, automated payment system. For automated payment system, we use 2 systems, which is generate QR code and load cell sensor. Okay. For auto payment system, in KASA Smart Recycling Center, we use redeeming the money and cash by scanning the QR code. So far, in this current stage, the way to generate the QR code have been found. We try to encode and decoding the QR code by using Python. We try to install the libraries for QR code and make sure the QR code can be generated properly. So for the load cell sensor, it's come with its analog digital converter, which is HX711 is used as a sensor at this current stage. The load cell is being calibrated by using non-weight object. We have installed the libraries SMTP to make sure the data will be sent by the email, so that the user will get the email that include the total weight and how much money they get from recycling. So this figure below show the Python code for the load cell. Secondly, is about the compactor. For compactor, as we know, the KASA Smart Recycling Center is designing the compactor to increase the area of the bin by compacting the trash before it's getting full. At this current stage, we have designing a prototype for a compactor. The compactor will be interfaced to Raspberry Pi using DC motor. And thirdly, the motor will be triggered when the sonar sensor detect the level of recycle bin is bin full. This figure show the reference code for compacting system.
Hi, my name is Aida Najiha. I'll be presenting our upgraded work. Firstly, for our monitoring system, the sonar sensor detect the level of recycled item. Then, the data being transferred to TeamSpeak. For the element of IoT, the TeamSpeak page could be previewed through mobile application. So, we had run the coding of sonar and transferred to TeamSpeak. For now on, we are currently work on the coding of sonar sensor for reading the data continuously. Other than that, before this we just prototyping our recycle bin by using cardboard and the size was just perfect. Then we prototyping the recycle bin by using acrylic board which more high resistant and better than cardboard. For load sensor, the data of load sensor being sent to the email and now we are in progress to make sure the load sensor read the correct reading by calibrated the sensor. For automated payment, we just install the library of QR code. Then we're gonna run the coding to produce the image of QR code. Next, for the Gantt chart. Over the past few weeks for this semester, our KASA Smart Recycle System had through the planned tasks according to Gantt chart very well. Basically, the project in progression of product simulation and prototyping project design. Next, for the current issue in the project and the solving method plans, the first problems are the sending email using Python. To send an email from Raspberry Pi using Python, we need to install the SMTP libraries. However, the problem is the installing process was failed due to the version update not successful. So, we had to solve it by get the updated version of Raspberry Pi until all the libraries needed could be installed. Secondly, for weight scale calibration, the load cell needed to be calibrated by using a non-weight object, but our load cell is not detecting any forces. Thus, the calibration is still unsuccessful. In conjunction of that, we need to do more research and try to look for the Python codes as reference for load cell calibration.
So that's all from us. Thank you.